This is seriously a superpower. Hey everyone, welcome to this video where we will look at getting started with test within Foundry. Testing is vitally important to make sure your smart contract operates the way it should and it doesn't have any exposure. Let's dive right into it. The bonus point, Foundry has a superpower when it comes to testing, and I'll show it to you. Okay, before we start coding, let's take a look at our smart contract. It's a basic Ether wallet that I got from Solidity by example. Upon deploying, we set the owner, which is basically the deployer. This contract is able to receive Ether. We make sure that only the owner can withdraw any crypto from this smart contract, and it has a get balance function to get the balance of the smart contract. All right, cool. Let's dive right into it. So Foundry is everything Solidity. And like any Solidity file, we need to define the license over here. So that's the first thing I'm going to do. All right, next up, we define the Solidity version. And once we've done that, we need to import some necessary libraries. Well, actually one. We need to import a test library and we'll need to import our smart contract. Awesome. Now let's set up a basic contract. And then we inherit from the test library that we just imported. Cool. Now we want to deploy a smart contract of the type Ether wallet. So let's define the variable Ether wallet with the type Ether wallet. So type Ether wallet and then the variable Ether wallet. We'll define an address for the owner, and then we'll make sure that this contract actually is able to receive Ether. All right, now we need to set up the test. And what that means is we will write up a function that deploys the smart contract. So the owner is the address that executes the transaction. So owner this, so address this, Ether wallet. We'll deploy a new Ether wallet. Cool. Now we have an error over here, and that is because we need to call it like this. Awesome. So this is the basic setup to deploy our Ether wallet smart contract. Now let's test that the owner is set correctly, i.e. the address that deploys this smart contract. Function, test, deployment, oops, it's public. And then we assert the Ether wallet, the owner should equal owner. And we say owner should be set correctly. Save this, semicolon, save this. Now we can run forge test. Cool, and the test passed. Now, regarding that superpower, so if you run forge test -v and a couple of v, you basically verbose testing, which means you get additional output of exactly what's happening when you run this test. The more v's you add, the more information you get. So over here, what you can see is the contract was set up and deployed, and then over here you can see that the owner is being tested with the address that's being passed, and this was all good. So this test passed and we can see that information. Let's move on to the next test. We want to test that once we send some Ether to the smart contract, the balance of the smart contract is correct. So we do function test receive Ether, and this will be public, be payable address Ether wallet, and then we transfer some Ether to it. Then I'm getting an error, it's a typo. And then we need to assert again, and we check the Ether wallet, and we call the function get balance, and we need to check, and the balance should be 1 Ether, and we say balance should be equal to 1 Ether. Close, semicolon, save. Now let's run the test again. Boom, we passed that one as well. We see over here the function test receive Ether. The contract receives 1 Ether, and then when we call the balance, indeed we see 1 Ether. All right, cool. But let's say we've got a bunch of tests and we only want to run one specific test. Let's do that in our next test, which is going to be a slightly longer one. Now we want to ensure that only the owner is able to withdraw Ether from this smart contract. So let's write that one. We'll say function test withdraw Ether as owner. Make this public. And then the first thing that we'll do is transfer some Ether. We'll say payable to the address of Ether wallet. And then we'll transfer. We'll do 1 Ether again. And this sends 1 Ether to the smart contract. Now we need to check the initial balance, which is address this dot balance. Now we set the amount that we want to withdraw, which will be, let's say, half Ether. And I forgot to close the parentheses over here. Now what we will do is we will simulate that the owner withdraws, and we can do that by utilizing a function called start prank. And then we pass the owner, and then we will call the function of withdraw on Ether wallet. And then we will draw the amount that we specified up there. And then we'll stop the simulation. Next, we'll check the final balance, which should be the initial balance minus the withdrawal amount. So uint final balance equals address this, balance, and then we assert, which is okay. We call the function Ether wallet get balance, and in this case it should be equal to 0.5 ether, and then we can say contract balance should be 0.5 ether, close parentheses, and need to remove this parenthesis. Oops. Next, we'll check that the balance of the account owner is increased by the withdrawal amount, so, which would be initial balance plus withdraw amount, and then we say owner balance should be increased with withdraw amount. Save this. Now when we run this test, what we can do is say dash dash match test, and then we say test withdraw ether as owner. Run this, and then what it will do is it will run just this test. We've passed it again. We can see exactly what happens over here. The contract gets deployed, the wallet receives 1 ETH, half a ETH is withdrawn, and then the get balance, half of it is withdrawn, and then the get balance is called, and the Ether wallet indeed only has half a ETH left because we've withdrawn half a ETH. Now let's run a test where we've changed the owner to message a sender in the simulation, and so that's our address that we're using to call the test withdraw ether as owner function, and this should fill, and it's failing. Now the reason why it's failing, if I scroll up, and over here we see 3 addresses that we console log: the address of the Ether wallet that we deployed in our test, and then the address of the Ether wallet owner, and then the owner that we defined. So these 2 owners are equal to each other, and the owner here, if I scroll up, is set here to address this, which is actually technically speaking the address of the Ether wallet test, which deploys the smart contract. So we don't deploy the smart contract from our own wallet, we deploy it through this contract. And that's why if you go back, set this to owner, save this, run the test again, it runs successfully. Boom. Now we could also write a specific test where an address that isn't actually the owner of the smart contract would try to withdraw, and that would then fill, but I just showed you how that would work in this test. I'm going to copy and paste real quick a test function that works like that. So this is test withdraw ether as non-owner, and it should fill. So if we look here, we transfer 1 ether again. This is an address that is not the owner. We simulate it again. We we set a check mark for a revert. We try to withdraw half an ether, and we set the flag true to if the transaction reverts, indicating the test passed. So withdrawal by non-owner should be revert. So if we save this, go over here, I'll remove this test, and we'll run this one specifically, and then so 1 test passed. Over here you can see it reverted. The caller is not the owner, so in that case the test passed because it reverted. All right, so now the final test that we will write is checking the balance function. Now we've used it repeatedly, but really we want full coverage of our smart contract, so we'll go ahead and write that up as well, where we say test get balance, it's public, and then over here what we do is we're going to send ether again, address to ether wallet, and then we're going to send to ether. Now we're going to check assert, so ether wallet, we're going to get the balance, and then we're going to call to ether, or the value we're going to check is to ether, and then we'll say balance should be equal to ether. All right, save this. Now let's try to run this locally, but ask Anvil to mimic the Scroll Sepolia testnet. Now this is a super powerful feature where you can ask a local testnet, your local Anvil testnet, to mimic any testnet without actually spending valuable testnet ETH, which is really can be hard to come by if your files are very large or it's very resource intensive. So what we can do is go ahead and say forge test, then I'm going to say -- fork URL. Then I'm going to go ahead and copy and paste the Sepolia Scroll testnet RPC URL, and then I'm going to again add the verbose flag so we get a bit more output. So if I run this right now, it's compiling, running, and it's going to run all the tests, and all the tests have passed. And what Anvil did is it's made a quick copy, so to say, of the scroll network, and we're running it local without spending any testnet ETH. And over here you can see all our tests passed, and that is super powerful. It's definitely powerful because one of the most powerful things is these traces, and it's how easy the overview is. You can exactly see what the steps are that Foundry has taken to test to call the functions, deploy smart contracts, transfer. And so if any of your tests fail or your code fails and you need to debug, this is a superpower. And then next to that, the ease and speed of Anvil mimicking or clone, so forking any network like Scroll, where you can run tests without spending any testnet ETH, as easy as passing a RPC URL, and you can also use environment variable. It's really awesome. That was it. I hope this video was useful. Please like and share if it was, and hope to see you guys in the next one.